Hi everyone. Today I'm going to take you through a tutorial of how to create and run a production line in Pashi. The production line we are recreating is a two-wheeler vehicle assembly line, which will represent the assembly process from the mounting of the engine and rear wheel to the vehicle frame to completion of assembly and the final QA check. In the pre-design phase of Pashi, we work with your team to connect production equipment such as torque wrenches, sensors, alarms, and cranes to the Pashi platform. These are represented as devices in Pashi, and their process parameters are defined as variables within each device. Pashi supports the whole gamut of deployments, ranging from completely greenfield to brownfield, using our flexible and easily extensible software integration and device connection layer. Our platform is able to seamlessly integrate with production line hardware directly or through PLCs, which are commonly used to control production equipment. We can also easily integrate with ERP, PLM, SCADA, MES, and other custom software systems. For more information, please check out our dedicated integration video, the link for which is provided in the description. Let's move on to the actual programming of the vehicle assembly line in Pashi. As you can see from the left-hand side menu, the various equipment used in this assembly line are listed under stage devices. Before we start adding devices to the stage and inserting logic, we have to add products and SKUs to the production line. We can do this by clicking on the Edit Production Line button. Once we have done that, we can drag and drop a stage block into the central window. Each stage in this line reflects the conveyor belt stopping in the real world for operators to assemble parts onto the vehicle. In this case, the first stage of the vehicle assembly line will consist of tightening operations to attach the engine and rear wheel. Tightening operations are done manually by operators using torque wrenches to tighten the screws to secure the parts onto the vehicle frame. To reduce human error and ensure that operators are correctly tightening the screws, we will create Poke-Yoke logic in Pashi, which will activate alarms at each station if the operation is done incorrectly. Having Poke-Yoke enabled for each assembly operation will reduce the chance of a defective assembly caused due to human error. We can add devices to the stage by dragging and dropping them from the menu on the left-hand side, and we can specify unique IDs for each device. To program the operational logic for the first assembly stage, we can insert the logic into the substage using Pashi's text-based autocomplete system. This system allows users to start typing the command that they wish for, and a prompt will automatically appear to let them choose a logical block. And depending on the block, subsequent prompts will appear to choose the device, variable, operator, and value. This makes it very easy to write the logic for your production process in Pashi. Additionally, there is also a drag and drop feature which you can use as an alternative to typing to create your logic. Pashi has logic blocks for conditional actions such as if blocks and action blocks such as set, which are used to assign values to variables. We will use these blocks in conjunction with device-specific action blocks to create the Poke-Yoke logic for tightening operations. We start by activating the first torque wrench and specifying the torque it should apply to tighten the screws. Next, we use an if block and set conditions on the torque such that if it is below the specified threshold when the wrench is being used, an alarm will be activated. This logic will ensure that operators are immediately notified when incorrect tightening occurs. Similar logic is used to enable Poke-Yoke for the rear wheel assembly operation. If the required torque has been applied during tightening, the product is sent to the next stage using the forward product action. Vehicle assembly lines often produce multiple variants of the same product, and the production operations for each variant may differ slightly. To deal with this complexity, Pashi allows you to create multiple substages with their own logic and each one is mapped to one or more SKUs. In this case, I am creating a second substage mapped to the type B SKU, which has slightly different process parameters used for assembly. Depending on the SKU of the product entering this stage, the corresponding substage will activate. Finally, we will add logic to the stage to specify how many products it handles at once, which in this case is 1. The wait for products block tells the stage that it should only start executing its logic once a product enters it. In the next few stages, the operators attach the silencer, fuel tank, front exterior panels, and the front wheel to the vehicle frame. The tightening operations for these stages are similar to the first stage, and we will enable Poke-OK logic for each operation. Once those components are securely fixed to the vehicle frame, the entire assembly is transported to a parallel conveyor belt using a semi-automatic crane. We will enable safety protocols for the crane by ensuring that the crane only moves when the hook that attaches the vehicle to the crane is completely secure. If not, then an alarm is activated and the crane is stopped. If the hook is secure, the crane completes the transfer of the partially completed vehicle to the parallel assembly conveyor. The crane drops the vehicle onto the next assembly stage and is deactivated. The last few assembly stages involve the attachment of the rest of the interior and exterior panels, headlights, speedometer, seat, and pillion handle. While most of these operations are completely tool-free, we can still enable Poke-OK logic for the ones that use torque wrenches. Once the assembly is complete, the vehicle goes to the QA stage where operators visually check the vehicle for surface defects and panel gaps before sending it for the road test. For this stage, we will use Pashi's built-in form device. Using this, we can design a form in Pashi and send it to any device that is connected to the platform. The first step is to set the station that the form will be sent to. Next, we use the send form action, and we will design the form using the form builder interface, which is accessed in the right-hand menu. You can drag and drop text fields, check boxes, toggle buttons, and many others from the list on the right. This form will be used by the QA operator to log quality issues and ensure that every vehicle that has completed assembly is ready for a road test. Now, let us see how to actually run a production line in Pashi. To do this, we go to the Live tab. In this tab, you can see the production line as before in the central window, but now in the menu on the right, we can add product batches to the production line and start it. On the left, we have a batch visualizer, which will allow us to monitor the progress in real time. We will specify a production batch of 2 and start the line. As blocks in each stage are executed, Pashi lights them up to give you a visual indicator of what is happening within each stage. The program executes and waits for us to complete and submit the QA form before indicating that the product is completed. The batch visualizer updates to indicate that we are 50% complete with this production batch. The process is identical for the second product, and now we have successfully produced 2 two-wheeler vehicles. We can now look at the genealogy tab, which gives us a detailed breakdown of the production process for creating each vehicle, with variable values and timestamps. Finally, let us take a quick look at what the actual code looks like in Pashi. Based on the programming that is done in the graphical interface, code is automatically generated in the Go programming language, which is similar to C. Software engineers can modify the production line by directly inserting logic into the program in Go, and this logic will automatically appear in the graphical interface. This means that production engineers without programming expertise can use Pashi's graphical interface, and software engineers can program in Go, allowing them to work together to modify and improve the production line. We have now successfully created, run, and modified a two-wheeler vehicle assembly line in Pashi. Thank you for watching this video demonstration of Pashi. It took 20 minutes in real time to graphically program the logic for this production process simulation. While in the real world, additional preparatory time would be required to connect the relevant production equipment to Pashi, this video is an accurate representation of how fast and intuitive programming and modifying a production line in Pashi can be. If you'd like to use Pashi in your own operation, or have any particular questions or queries about the usage or deployment of our software, feel free to email Soham Sankaran, our founder and CEO, at soham@pashi.com.